All right, welcome back to Professor Scangrella. In this session, we are going to look at using simulation tools to analyze our circuit. Now, for today, we're doing something very basic. So we have a basic tool. We'll be going through Multisim Live. So I have a couple of steps here. The first one is so that you can create an account using Multisim Live. If you just search for Multisim Live, you will be able to get it and create an account. And I have an account. My account's already signed in, and this is what I'm going to show to you. Then you will select components to create the circuit. Following this, you're going to change the values of your components to reflect the circuit that we have here. Then you're going to add your measuring instruments. Following this, you will run your simulation and record your results. So after you sign in, you want to go and create a circuit. And then you will see your interface. Okay, now we're going to follow the steps of adding the components. Of course, if you see our steps, first thing is to select components and create the circuit. So our circuit is, we need a power supply, we need a resistor, and we're going to add a ground symbol right here. So on this side here, I see the ground symbol already. I'll click on it and include it here. Then I will go here and select a power source, and I'll select a DC voltage power source here, and then we just need one resistor. Here's a symbol for a resistor. Click on it and select a resistor, and I'll click on here, and of course I can rotate it this way. And so the next step is to connect all the components together, and so I'm doing this now. All right, then the next step is to change the component value. So just double click on this component and we can change it to 25, just like we had in the diagram. All right, so if you look at our diagram here, we have same circuit, 1.2K and 25 volts, and we are finding the current and the power. So the next step after we have selected the components is to change the component values is to add the measuring instruments and to run and record the simulation results. So now we need to add the measurements. So we're going to add, I'm going to add the V here. So I'm going to add the current and voltage. So this here will give me the current and voltage. Here, now I don't have power, so I'll have to multiply the current times the voltage. So here, I think that's it. That's all we need. So again, to run the simulation, I just hit play, and I'm just going to make it a little bigger so you can see it. All right, there we go. So you can see here that I have 25 volts coming from my supply, and the current is 20.833 milliamps. And so to find the power, I need to multiply voltage times current. And so I can record the simulation results over here. So this is what I found using analysis. So I used the equations that we used before, and I found the current to be 20.83 milliamps, and the power I found to be 520.8 milliwatts as well. So again, using the simulation results, the current is, so straight from the simulation, is going to be 20.833 milliamps. So 20.833 milliamps. And the power, of course, is going to be the voltage times the current. So it's going to be V times I, which is equal to 25 volts times 20.833 milliamps. Now again, you need to know how to put the milliamps in your calculator. Some calculators have an EXP button where you put 20.833 EXP, and then you put -3. So it's the same as times 10 to the -3, and it will enter this for milli for you. So if you put it correctly in your calculator, you will get the correct answer. Some other calculators use the EE button as well. So again, the power that when I calculated 25 times 0.02833, it gives me 0.70825 watts, which is the same thing as 708.25 milliwatts. So it's a big difference to what I calculated. So let me just make sure that I have mine correct as well. This should be 25 times 25 divided by 1200, and I'm getting, so let's see if there's an error. 25 volts, 1.2k. That's the same thing that I have. Okay, let's see, 20.833. Yeah, the answer should be the same. So this should be 5.520.82, which is the same as 520.82 milliwatts. All right, so we have come to the end of the simulation section. Again, it's very simple. As long as you create your circuit, you can run the simulation, you can add your instruments, and that's it. We've come to the end. Again, this is Prof. Scangrella signing off. See you on the next one.